Get your tuxes and paddles ready as the FCC prepares for another auction. Plenty of companies aren't waiting around for more C-band as billions of dollars pour into programs and thousands of new satellites are filed for launch.
Spin launch is dead. Long live spin launch. Space catapults aren't the only providers pivoting into other technologies this week, though, as we see expansion into comms, missiles, and electric propulsion.
These eyes in the sky can't cry, but they would if they could this week as we see numerous on-orbit failures across VLEO, LEO, and GEO. They range from exploding ComSats caught by Earth observatories to space telescopes being chased by tumbling spacecraft through the atmosphere.
Welcome to this week's episode of Space Times Podcast. As always, I'm Harrison Lambert.
Here with Paul Mayer.
Excited to share this week's space industry updates with you. We hope you enjoy the episode. Subscribe to our newsletter if you want the written breakdown of our episodes emailed to your inbox every Monday morning. Drop us a comment on our LinkedIn or Blue Sky with anything you enjoyed or would like to see. And as always, listen weekly on Spotify, Apple Podcasts, YouTube, Substack, or wherever you're receiving this signal.
This week, we had the privilege of interviewing Alexander Ryan, founder and CEO of VXB Aerospace. We'll start with an excerpt from that interview before returning to our regular programming of communications, propulsion, and monitoring.
Welcome to a special episode of the Space Times Podcast. This week we are exquisitely privileged to have Alexander Ryan, the CEO of VXB Aerospace, joining us. Alex, thank you so much for taking the time.
It's my pleasure. It's good to see you again, Paul. It's nice to meet you, Harrison.
Great to meet you.
Give us sort of the top level, the Kármán line view of what VXB is doing. What's the core problem you're solving?
VXB, we've built one of the, if not the first platform that automates the design of fairly complex hardware systems using generative design algorithms. And we're not just designing them for performance. We're also creating systems that include a bill of materials, the manufacturing processes required to create them quickly and efficiently, as well as any other sort of simulation metadata for the engineering teams to understand exactly what it is that they're going to integrate into their broader systems.
Give us a little bit of a picture as to the level of granularity that we're talking about here.
Originally, we were sort of doing the integration of existing off-the-shelf parts. I mean, back when I was doing my PhD, which was sort of the original genesis for the idea that became VXB, I was actually pulling eBay listings. So I was grabbing, different parts off eBay and then using the algorithms to pull them together and minimize cost as much as possible. In fact, the first one we built, once the algorithms were done, it took 2 days to create the design. And then because you had all the listings, you could just order them. It was built 2 weeks later. But since then, we have evolved to going, I guess, further down and starting at essentially billets of material. So we're running fairly sophisticated manufacturing prediction models that work with CNC machining, 3D printing. And so you can create these fairly complex components like Hall effect thrusters, for example, which of course use a whole range of different unusual materials. And you can essentially determine which manufacturing processes to use. So for example, one of the Hall thrusters that we built using our software used a combination of like a sort of a copper 3D printed material, as well as this like high magnetic saturation material that was CNC machined. And the algorithm determined that was the fastest and cheapest way to make that component.
So what do you see the biggest opportunity here being? Like,
we see ourselves as a tool for a range of different types of companies. Originally VXB was a hardware company, so we're using these tools internally to design propulsion systems primarily. And the original goal was to just be a seller of propulsion systems. But a year or two after we were founded, we spoke to the folks at JPL. They looked at our tech and they were like, this is a software platform. You should be selling this to people to move faster and build their own technology. And what was cool out of that was when we decided to pivot to being a software company and making this internal tool a product was, for example, propulsion companies suddenly became potential customers. Let's say they want to build a new type of propulsion system that isn't in their existing product catalog. They can use our platform to build out a new system. So, component suppliers could be using the tool, but also, it is a vertical, quote unquote, vertical integration enabler. So we work with a customer in the US that is essentially using our platform to create their own systems and own essentially the supply chain for that system. So all the way from where you source the materials, what sort of manufacturers you work with, and then just have that propulsion system integrated into their satellite platform. So it's kind of all of the above. It is just a tool for people to move fast. The platform, it can be used to generate full models from initial basic requirements. So when you start up the software, whatever you're designing, whether it's an antenna, a power system, a satellite configuration, you get prompted on what sort of requirements you'd like to set. And these are things like performance thresholds. I'll use thrust as its best example, thrust, for example, for a thruster.
Yeah.
And then also overall cost and lead time. And then the platform generates up to 200 solutions. We generate thousands, but we usually have the top 200 solutions available for engineers to choose from. And then when they've selected a design, it reveals the bill of materials, the manufacturing processes, the predicted cost, and all the performance trade-offs. And that essentially takes up a lot of the end-to-end, I guess, prototype or initial ideation or creation of components. You can use this platform with existing CAD tools and simulation software, but usually the way it fits in would be, let's say you have a pre-existing CAD design and you want to make changes to make it more manufacturable, you want to try out different materials, you want to see if there's any improvements you can make to it. You can run that through the system. And then at the end, there's additional simulation tools like ANSYS tools, for example. You can essentially cross-validate the solutions. But internal to the platform, we do have all of our own simulators. So that's sort of a key part of making it run quickly, is having our own simulators. The idea is to essentially speed up the ideation or the idea creation process. So you're getting this range of different prospective designs as quickly as possible, and then building, testing, cross-validating, but it does get you to that prototype point very, very quickly.
Sure.
Long term, I mean, as these models get more and more sophisticated, there is a scenario where, the trust is at a point where they go, well, we've built 100 components with this software, and every time we go and check it, it matches, and we don't have to worry about it. Then maybe people drop those other tools more and more. But
Sure.
We're starting in an industry where there's a really high standard for validation and trust.
Right.
It's kind of the benefit and the challenge of starting in this industry. And so, near term, we do see it as sort of working with those tools, but just getting people to that, initial configuration and solution. And usually it's very, very close. It's very, very close. So there's very little changes that need to be made after the design is selected.
Tell me a little bit about sort of where you found your traction and who your beachhead customer has been so far.
Yeah, that's an awesome question, because going into this, our assumption was that it would be like small startups that wanted to move really, really quickly, could use our platform to, build quick. And we have found that to a certain degree, but, I guess right after we did the pivot, we started speaking to some primes, like off the bat, we just sort of showed them our technology. And we thought, like, we spoke to a very large Japanese customer, big household name. We can't say who they are at the moment, but it's very exciting. But when we spoke to them, we were looking at our pipeline of different customers. We're like, wouldn't it be funny if our first customer was just like Japanese prime? That'd be kind of weird. And that ended up being our first customer. We've found that primes, or like large organizations, have been a lot more quick to adopt this technology and start integrating it. And I think there's probably a variety of reasons for that. Most likely they sort of see their own internal process and they see how these sort of new scale-ups, how fast they're moving, and they're like, we want these internal tools to then move at the same speed as a startup. So it wasn't like startups trying to move at the same speed as a big company. It was these big companies trying to move at the same speed as a startup, which was kind of cool. So most of our early traction has been with big companies. And now we're sort of moving towards scale ups. We're sort of moving from big companies down to small companies, which was kind of counterintuitive going into this, but it's been pretty exciting to see that. An example of one of these projects we've done with this prime, I can't say exactly the project, but basically it was something to do with a satellite. And it was a design process that typically takes 6 months to a year to do. And our software was generating solutions that exceeded the performance of what they would have got internally through that 6 months to a year process in less than 12 hours. They got very excited by that. And actually, another really cool thing that happened was there was something about the design that was very unusual. One of the designs that got spat out had very high performance. It was very unusual looking, and we had like a meeting. They're like, I don't understand why, this thing is placed here. And we're like, did the algorithms just found this solution? And we went and reviewed it, and it was like we'd discovered an entirely new way of configuring this. And now that's been like folded into their own knowledge about how this sort of satellite part is produced, which was a super exciting moment for us because, on one hand, it's about speeding up the process of creating designs that just work or are fast to produce, mass manufacturable. But then there's a whole other angle of like, if you're producing lots and lots of different designs, there's an opportunity to find all of these really interesting, non-intuitive solutions that engineers just don't have the time to find or may have missed. And so when we found that sort of in situ in a sort of a customer environment so we found them ourselves internally, but when someone else ran the platform and found it, that was really exciting.
How can our listeners help out VXB?
Yeah, I mean, if there's any more companies out there that need to iterate on their hardware as fast as possible, if they have any bottlenecks in component supply or even like system level design, we're an open door. So we can spin up our platform. It takes us under 2 to 3 weeks to get it running on a new vertical. It's very generalizable. So if anyone wants to collaborate on adding a new capability, or everyone has an existing challenge, which is our current lineup, so like a propulsion problem or an antenna problem, a power problem, a satellite configuration problem, we're an open door, and we're super excited to work with as many folks as possible. We're also about to kick off our next fundraise. I know we finished recently, but we're about to kick off our Series A. In this horizontal world, we can address a lot very, very quickly with, fairly capital efficiently. So, we're raising our Series A pretty soon. So, we're excited to talk with as many investors who are interested in this space. We're looking for sort of strategic investors who are interested in this idea of software for hardware, and that's what we're really interested in. Yeah.
Our main topics this week include communications, propulsion, and monitoring. To start things off with communications, we have Spain committing $2.3 billion to IRIS² for national military satellite communications. So this is a huge check to write, although unlike Poland's $750 million contributed to IRIS² last week, this is being spent on Spain national military satellite communications. So a bit of an inversion of that relationship. With Poland, they were getting a few satellites for their payment. With Spain, they're committing some of their satellites to this constellation. So it really is a consortium play with a variety of different types of contracts, but it's really intended to pull together all of Europe's communication capabilities into one constellation that would allow them to rival Starlink and Starshield by extensions. So the full constellation isn't military SATCOM. It's kind of a mostly commercial satellite communication that's spread out across multiple different shells. So not all of them are LEO satellites, which is pretty similar to what we see with Starlink. But about 18 of them are in MEO, 264 are in LEO, and 10 in VLEO. So it's not clear where exactly these Spanish satellites are going to sit, but I would expect them to sit in LEO, as these MEO satellites are usually for aggregation of the LEO satellites to kind of relay data between them, usually using laser terminal links. The 10 VLEO are very interesting. I don't see that being used for military satellite communications. I'm not really sure what it's used for. I think they were talking Actually, there was some talk about VLEO being kind of like a was it a cell tower, like a relay cell tower in very low Earth orbit. So kind of helping bridge some of those communication gaps and speed up some of the communications through more of like a bent pipe application. Whereas the 264 and LEO are kind of what we've come to see as traditional communications constellation. So this full program, the price tag is up to $10.6 billion. Spain shipping in like a fifth of that is a large contribution.
Yeah, it's a really big buy-in from Spain. And the fact that Poland was effectively buying satellites and Spain is donating satellites in so many words is a pretty interesting inversion of that investment. What you said about sort of the MEO satellites and potentially the VLEO satellites sort of serving as different layers of infrastructure, with the LEO satellites being sort of the primary backbone, the meat and potatoes, if you will, of this communication. The communication constellation that they're working on here. I think that makes a lot of sense. I can just imagine that the MEO satellites are effectively serving as the infrastructure. Your LEO satellites pass information up to the MEO satellites to then transfer elsewhere, rather than the LEOs needing to go laterally. And the MEOs are able to go basically anywhere in the constellation or directly to ground. And then sort of to your point, some of the VLEO satellites would be able to either serve as sort of last mile communication. If there's a spot that needs maybe a closer signal, something that can come in at a higher power signal because it's half the distance that maybe something in LEO would be, meaning that the signal is going to be 4 times as strong. That's going to be easier to get around some of the more traditional jamming technologies. So I can see there being sort of bent pipe applications for both defense and commercial applications. I am actually not at all surprised to see Spain standing up the defense portion of this first. I know that this is intended to be dual use, that there's going to be a big commercial contingent for the IRIS² constellation. I would not at all be surprised to see sort of the first thing that goes in, the first capabilities and the first customers served to effectively be the defense needs. But a huge investment, like you said, we've seen roughly $3 billion going into IRIS² with a $10.5–11 billion price tag. So we've seen 25 to 30% of this already funded over the last couple of weeks here.
Yeah, there's also large amounts of spending being given to SpaceX for military satellite capabilities, but this is on the launch side of things. So SpaceX won a $1.6 billion contract order through the NSSL Phase 3 Lane 1. We've talked about this a couple times in the past few weeks, where they increased their total spending by like $15 million. Part of that seems to be going towards here. They also added companies like Relativity Space and Impulse to the list of launch providers they can buy from. And they were, talking about doing some more like flexible launches. That's where the increase of funding was going towards. So this order is for 18 Falcon 9 launches at $1.6 billion price tag. That's about on par with what Falcon 9 usually costs for a dedicated launch. So pretty standard there. Usually it's around 75 million. I think the math works out there about right. For these launches, they are launching airborne moving target indicator sensing and targeting satellites, as well as some communication satellites. So it's very on par with what we've seen coming out of the SDA. For PWSA primarily, this seems like it's related mostly to the launch of some of these like L3 and Sierra and York space satellites that we've been seeing going up, but it could be for some other national security spacecraft that aren't known, or potentially even some of the satellites that SpaceX has won recently. As PWSA pivoted away from the communication layer, it could be launching some of SpaceX's own satellites to fill out this AMTI and communications need for the government.
The AMTI sensing and airborne moving target identification need is something that a lot of the companies that we've actually spoken with, and a lot of the companies that I've spoken with prior, this is a use case that everybody knows the military has and everybody knows that the military needs, because it basically boils down to missile tracking, right? Like that's the big sort of golden goose that everybody's going after. That's the white whale. And so seeing that SpaceX won the launches for them, 1.5 dozen launches to get these assets up into orbit. To your point, this order, this tasking is basically just for the launch. So in my mind, I'm hopeful that a lot of the folks that we've spoken to are in consideration and are still competitive for some of the vehicles that will ultimately be contracted and awarded these missions. And I'm hopeful that it doesn't wind up just being an 18 Falcon 9 set of Starshield launches that wind up going up, because there's a lot of really innovative ways to solve these problems using multiple different payloads, multiple different types of sensors, ranging from infrared to SAR to optical. But there's a lot of different ways that you can sort of solve this problem, and having multiple different solutions is the only way to truly ensure reliability and redundancy. It's the only way to truly ensure that you do not have a single point of failure. So I'm sure that the Space Force isn't just handing this entire contract and everything derived therefrom to SpaceX. But I'd be pretty surprised if SpaceX didn't end up winning a good portion of those sort of vehicles. We'll say there's 18 rockets full of vehicles. I'd be surprised if SpaceX didn't win any of them, but hopefully they're not winning like half of those rockets worth of payload.
Yeah, it certainly would be good for SpaceX, but I'm still not sure how they do AMTI stuff. They got there was like some announcement that they got some AMTI stuff a couple months ago, but I was doubtful they were actually building those satellites because they've never talked about it. But since it's national security, it might just be something they don't offer commercially, and it's kind of sensitive topic. But now that they're a public company, I feel like it'd be hard to hide.
Most of these conversations don't need to be publicly reported, but like all of this would ultimately need to be disclosed in some capacity or another in investor or financial reporting. So like simply not enough time has passed at this point, but like I would be surprised if we didn't get more insight into things in the coming quarters and months here.
For some of the more traditional geocom providers, we have a new auction plan from the FCC. So this is an upper C-band auction that's planned for July 2027. We've seen a couple of auctions recently. There was just a regular C-band auction. That was all for terrestrial communications providers. It was snatched up by companies like Verizon and AT&T and T-Mobile. We also saw a K-band auction recently that was bought by a lot of constellation companies, as well as a few bigger ones like Viasat. But this upper C-band auction seems to be split between three main, like, kind of legacy telecom providers. One being SES, the other being Eutelsat, and the third being Telesat. So SES predicts they're going to spend $3.6 billion buying up spectrum rights. Eutelsat expects they're going to spend $750 million, and Telesat did not provide a prediction as to how much they're going to spend and didn't comment on the filing itself. These costs associated are to actually buy the spectrum rights, but in order to actually utilize it, they're going to need to launch new satellites and move around existing ones. So we expect to see some contracts come out for manufacturers for these companies to fill that need. We've talked about SES recently when they're buying satellites from like K2 Space, but these seem to be more traditional geo satellites. So maybe companies more like Thales or Airbus or Boeing to fill out these needs. It's a bit of an interesting relationship because the FCC does provide funding for these operations. Last time in 2020, these companies received $9.7 billion in funding for accelerated relocation of their assets. They expect to do this by 2030 this time around. So it's a pretty quick timeline to get what SES says is 5 new hybrid KU band satellites, as well as 2 in-orbit backups. That's 7 satellites in about 3-4 years. At that price tag, that's pretty reasonable. It's expensive, but geocom satellites tend to be. But this whole thing, is a pretty big move. It's pretty challenging for the FCC to manage all this C-band. It's 160 megahertz in the upper C-band, so 3.98 gigahertz to 4.14 gigahertz. This is pretty popular amongst the aviation industry, as well as wireless, other satellite applications in the media industry. When the FCC opened the auction announcement, they received like 100 filings in kind of protest or raising concerns about this. So it's going to be a kind of stressful job on the part of FCC to figure out how to manage all the different parties involved and make sure that this allocation is cleanly implemented. But it's pretty critical for a lot of 5G and 6G rollout of non-terrestrial networks coming up in the future.
SES is setting a very ambitious target here with what they're going to be able to deliver on. But sort of to your point, because they're going to be, for the most part, acquiring these satellites from some of the incumbents, they're probably not going to be getting all of them from one spot just because that timeline is so aggressive. So they probably will be getting, one or two satellites and one backup from one provider, and one or two satellites and another backup from another provider. They'll probably have to dish it up to at least two different manufacturers themselves. But yeah, a very ambitious and very impressive goal here that they'll be achieving towards.
Speaking of ambitious, Amazon has filed for 5,105 direct-to-device satellites. This will primarily be using Globalstar spectrum. Their announcement's a bit coy about what exactly they're going to be doing with this constellation, but it largely seems to be centered around the L-band spectrum that they bought from Globalstar very recently, although part of their announcement says that that'll be operated along S-band, which is a lot more traditional for direct-to-device compatibility. They do have some S-band spectrum for the Amazon LEO constellation, so this will be operating in alongside their first and second gen LEO satellites, which they just recently started operating. Although there's still thousands of satellites behind on deploying that. It will also operate alongside Globalstar's Hive LEO and C3 satellite constellation across 5 orbital shells, 3 in mid-inclination for highly populated areas, mostly around the equator to 20, 30 degrees inclination, as well as 2 high inclination shells to cover some of the more polar gaps in that coverage. The announcement kind of conspicuously avoided saying that it's for, multimedia or backhaul kind of for broadband capability. So it's not like this multimedia messaging capability that we see mentioned from companies like Starlink and AST Space Mobile. Although they are kind of talking about how you can use it for that purpose, they just don't explicitly call that out. They are talking a lot more about SOS services and the contract they have with Apple, which is a lot lower bandwidth, but still like mobile capabilities. But that's usually all L-band can handle. The S-band should get them up to broadband kind of capability, at least for mobile devices. But they talk a lot about, like Bluetooth devices and IoT devices. So it seems like they're still pretty heavily targeting the B2B kind of market, which is what LEO is more well positioned for. Although they're talking about, being able to move data up to the satellite, doing some processing and then bringing it back down for like higher responsivity. But, it reads to me like they're also talking about doing on-orbit compute with this, which could play in well with the more centralized kind of data centers and operation centers that they tend to operate for. The other main issue with this filing is that they just kind of came off of double secret probation with the FCC when they missed their launch target for their initial deployment of LEO.
What do you mean came off? It's like they're still picture is over the doghouse.
Yeah, it's pretty brazen to file for more satellites when they're behind on deploying their original satellites. But a lot of companies, like, they're not the only ones doing this. There's a lot of companies that are just filing for massive amounts of satellites and figuring, the FCC is just going to slap them on the wrist that they missed the target. And if they don't, then they're successful. They'll just figure it out along the way. So I would be surprised if somebody doesn't contest this filing. But seeing as how SpaceX just filed for 100,000 satellites of their V3 Starlink, I'm not sure it will come from them. Although historically they've loved to get in slap fights over at the FCC. So I would expect some more drama out of this filing in the next couple of weeks.
A while ago, you said there need to be consequences for folks failing and missing on their deliverables because otherwise there's no incentive to follow through on anything. It's just sort of a land grab. And then, you get a whole bunch of half-cocked attempts and everything is really poorly executed. And while that's very true, and we will see more attempts like this, the sort of the justification at the time was that, we aren't going to rescind Amazon's license. We're not going to rescind their spectrum for the LEO constellation that's going up because we don't want a single point of failure. We don't want a monopoly in the market. So I think you're right that we'll definitely see a little bit of hand fighting here and there. I think SpaceX is probably going to try and throw some mud, and Amazon will certainly throw some mud back. I think that the FCC has already sort of shown their hand a little bit, that like, look, until there's enough people able to provide this capability, until there's enough players to where we can actually punish somebody and threaten to effectively remove them from the market, then doing so at this state just further solidifies what is more or less a functional monopoly for SpaceX. So, I think we're going to be in this state of sort of helter-skelter, Wild West, until we can get to sort of a half dozen different potential solutions and providers who are able to start to see a little bit more diverse of a market share.
Yeah, that's a fair point. It would, at this point, kind of just be shooting ourselves in the foot to kind of enforce this more strictly, as China's filed for hundreds of thousands. I mean, we're at like 2.5 million satellites filed, and China's launching at a fast cadence at this point. So, stopping ourselves from deploying for any reason that's just kind of logistical is probably not helpful.
But I mean, you're right that the price that we're going to pay for that is that some of the satellites are going to be installed backwards. Right, like some of the stuff is just going to come out sloppy.
Lastly, for communications, we have Sphinx Defense winning $287 million for a strategic communications software. This is under the United States Space Force Evolved Strategic SATCOM mission planning through an other transaction authority agreement. So this software is intended to help the Space Force plan out their communication layer. This is becoming increasingly important as they have a more heterogeneous capability, and they're advancing more advanced kind of communication technology, whether it's through PWSA or any number of other communication satellite capabilities. We talked about like the advanced high frequency satellites they've been launching. You have companies like Astranis building their own satellites for this. There's just a number of different communication satellites that are going up, and this is getting to be a more difficult, complicated kind of network to manage, and this helps the Space Force actually navigate that and plan better for it. And particularly, I think when they talk about some of these advanced like frequency hopping capabilities with the proliferation of GPS jamming and all of that, they need to be able to kind of foresee switching communication satellites on a whim in order to respond to adversarial interactions for both terrestrial and in-space communications. In Propulsion this week, we have some interesting news. It's not just rockets this week. We have Spin Launch rebranding to Meridian Space very quietly. There wasn't like a news report on this, but I noticed that Spin Launch's website is now pointing to Meridian Space with a statement that in July 2026, Spin Launch has legally changed its name to Meridian Space Incorporated. This is reflected in their Delaware Certificate of Amendment. Meridian Space says they continue the same corporate entity, team, and mission under a new name, although that mission part is doing a lot of heavy lifting, as nothing on the Meridian Space website mentions the Spin Launch orbital capability. So Meridian was a constellation they announced about a year ago. It was being built by Kongsberg Nano Avionics to create a satellite that could do a communications constellation through the Spin Launch platform, which everybody that works in our industry knows is a high G launch capability that will liquefy just about any satellite that we currently build. So the reading between the lines there is that Nano Avionics, Kongsberg Nano Avionics, was building a satellite that's highly resilient to high Gs and can be placed into orbit. It now seems that they are abandoning their launch platform that's long been kind of in development, but has never really done orbital launches. They've done some like test launches, but they were never very clear on how far they actually managed to launch anything. It seems like they're finally giving up on that effort and focusing all of their efforts on this communication constellation, which, to be fair, is a pretty unique offering amongst satellite communication constellations. It's a flat pack kind of satellite that sort of assembles on orbit and leverages a few interesting technologies, at least from what I can see of the design. One is that it's so flat that there's basically no traditional systems on board. The only thing that you can see is like a laser terminal, which you could probably get a lot of your position, navigation, timing, a lot of the ADCS solutions from. But notably, I don't see any star trackers or reaction wheels mounted on it. So it's a little unclear how they're actually managing to point this thing. Although part of that may be due to the uniqueness of their antenna, which they're using a reflect array antenna. So instead of using phased array radios that can adjust the direction just off of the emitter, they actually have the horn pointed towards this, what looks like a phased array, but is actually shifting the reflective direction. That should give them a better cost efficiency, but also higher throughput potentially, and allow them to kind of point without pointing the satellite too much. So it seems like they have come up with a pretty unique solution. They claim that they're able to launch 250 of these satellites on a single launch vehicle. And interpreting that as a Falcon 9 and not, space launch or spin launch. But that's pretty significant. They say 250 will get you a full constellation in one deployment. If that's true, that's a pretty big shift. I think it gives a lot of people the ability to launch their own communication constellation much quicker than we've been seeing in the past. I find it hard to believe that the actual throughput and capability of it would be able to compete with something bigger like a LEO or a OneWeb, but still impressive the fact that you could buy one launch vehicle full of satellites and stand up a full communication constellation. So definitely an interesting pivot for spin launch. We'll see how that plays out in the near future, hopefully.
Yeah, it looks like the market for liquefied composite really just didn't materialize the way that spin launch might have hoped. I think the bigger thing to take away here is how similar their flat packed satellite sounds to some of the folks that we've had the privilege of speaking to earlier. The fact that they are super flat packed means that they don't have room for a lot of the typical ADCS equipment that we normally see. So because they're getting everything into a single fairing for a single launch, they simply don't have the volume in order to make room for magnet torquers or torque rods or reaction or momentum wheels, anything like that. And so this was actually something that our friends at Samara Aerospace were working on with their sort of proprietary ADCS solutions, the MSACs that they've been developing and working on. It sounds like, sort of to your point, that Meridian has been working on the antenna or radio side of things, but they've been working on another layer of that sort of cake that allows them to effectively point without needing that cumbersome and volume intense controls setup that they would otherwise need in order to be able to point in the right direction for the communications products here. But very interesting nonetheless.
Yeah, I'd be interested to see what the business looks like, because if Kongsberg is building them, and it sounds like they'd be selling them to people that want to operate their own constellation, I don't really see how they fit in other than a middleman, which I can't imagine is the most profitable place to be.
It's definitely not going to be the most profitable place to be, but I would imagine if they're trying to, if folks want to operate them themselves, there's going to be some model of broader sort of fleet management that Spin Launch is able, that Meridian is able to bring to bear, that allows them to sort of carve out that niche as the middle person between the ultimate customer or operator and the manufacturer and their supplier themselves.
The United States Space Force has also awarded $250 million this week to Allpoints to expand satellite processing at Vandenberg. So this is also a national security space launch award, although it is coming through the Portfolio Acquisition Executive for Space Access, and it's for vehicle processing commercial solutions instead of what we've been seeing for like launch provisioning. So this is intended to increase commercial capacity for space vehicle processing at Vandenberg by 2029. This is the third NSSL SV CSO since 2025, the first two being split between Vandenberg and what's the one in Florida? Cape Canaveral. So it seems that having a second contract go to Vandenberg emphasizes the priority that the Space Force is placing on Vandenberg's launch capability. We talk a lot about launch sites being one of the bottlenecks of access to space. This is a great step towards relieving that pressure. I find it interesting that they are still putting money into just building out a particular launch site rather than opening new launch sites. Although $250 million is certainly not enough to open a new launch site. So still good to see. It's for commercial integration, which also means that, even though it's coming through the National Security Space Launch Organization, and it'll most likely be used for national security launches, it's also going to benefit the commercial space market. So great to see the government spending something that's going to be kind of dual use between national security and commercial space to expand the speed at which we can deploy new capabilities to space.
Space is a logistics play at this point. That's how we have to maintain our advantage. So throwing $250 million at improving the cycle time, improving the turnaround time at Vandenberg, one of our 2 live launch sites here in the US, or I guess 3 if you include Texas, but one of the very few actual launch sites that we have is a great investment. Though, I don't know that $250 million is that much less than one would need to stand up a new launch site, given that the price point for Rocket Lab's Alaska base is $266, but we'll see.
Well, that launch site already exists. The $266 million is for the launches themselves. I think it's to stand up their own launch pad, but to stand up a whole new launch site, I think, is a bit pricier. So what you're referencing is the announcement this week that Rocket Lab has gotten $266 million to the United States Space Force deal for their HASTE rockets. So these are suborbital versions of their Electron rockets that are usually used for hypersonics testing. And up till now have been launched out of Wallops in Virginia and out of their launch site in New Zealand. So this adds a third launch base to their capability up in Kodiak, Alaska, which we don't hear much about the launches out of there. It's primarily used for missile testing. But, last time we talked about it, well, we didn't talk about it. This was before we started the podcast, but Astra used to launch out of there. So the Kodiak launch base has been around. I like how you just wrote off Wallops and Kodiak. They're not real launch bases. But, it is used. It's just not used a whole lot for orbital launches because it's so highly inclined. It's good for polar insertion, but it's really hard to get to, and it's not a huge launch base, so it can't support large launch vehicles like a Starship or a New Glenn. And I don't think, we've talked recently about really cold spaceports being a struggle for some rockets. So I'm sure, Falcon 9 is doing perfectly fine out of Vandenberg and Cape Canaveral. There's no reason to add that as a capability. So definitely interesting. HASTE got a huge contract earlier in the year, so continuing success for that rocket for Rocket Lab. The $266 million will cover 12 suborbital launches with up to 6 additional launches, with the first launch no earlier than the end of 2026. So overall, just great to see Space Force funding Rocket Lab either through HASTE or the Victus Haze missions, just pouring money into that launch vehicle capability. At this point, Electron's well matured, still has 100% launch rating or launch reliability. So that's great to see. I'm just hoping a lot of this money helps expedite their development of Neutron rocket, which is still delayed to this point. So good to see Rocket Lab launching, although I hope very soon we'll be adding Neutron to those launches.
I do think some of the challenges we've seen out of ISAR from Germany have been related to how high the latitude for the Norwegian launch base that they're using is. So ISAR their Spectrum vehicle is launching something larger scale than the HASTE vehicles that we're going to be seeing Rocket Lab launch. There's still probably a little bit of sort of overlap there in the specialization that needs to happen to deal with the colder weather and to deal with the higher latitude in order to achieve in those sort of unique polar orbit launches. So hopefully hopefully ISAR is able to take some notes here, and we'll see both Neutron coming live and the Spectrum coming live in the near future here.
The other happening up north this week is that Nord Space has funded its second company, North Vector Dynamics. This is for missile development. North Vector Dynamics holds a $4.2 million contract with the Defense Research and Development Agency out of Canada. They are testing hypersonic interceptor missiles. And this investment from Nord Space is meant as sort of a partnership. So the last company they funded was, I believe, Wyvern for Earth imaging. Nord Space has also talked about developing their own VLEO satellite, which I thought was a much more useful use of their money. I think this investment also makes a fair bit of sense. At this point, Nord Space hasn't launched anything. And when they do launch, it'll be their first version that's not, hugely orbital capable, but it is. But with a lot of these like early versions of rockets, I see the value towards hypersonics being more clear. We talked about Rocket Lab with Electron, that being their first rockets, relatively small launch capacity, but it is good for things like suborbital hypersonics testing. So, I think the synergy here between NordSpace and North Vector Dynamics is good. It will accelerate Canada's capabilities in missile defense, which has become an increasing need for the country. And along with the investment, NordSpace intends to provide their Hadfield 150 resources to North Vector Dynamics. So that's their designs, their manufacturing, the logistics around that to help accelerate the development of those missiles. Lastly, for propulsion, we have Impulse Space unveiling their Electra electric propulsion solution. So the Impulse Space has primarily, or actually up to this point, only been a chemical propulsion company. They're focused on in-space logistics, so they've launched their Mira spacecraft to do orbital transfers and orbital tug operations. They have their Helios kick stage, which is intended to push satellites from LEO to GEO at a high speed, given that it's a chemical thruster. And that's one of the companies we recently mentioned with the NSSL contract. So they've gotten some interest in that capability. This electric propulsion is an interesting deviation away from what I considered their core thesis, which is the ability to move around quickly in space. Electric propulsion does not give you that. You can move pretty far and very reliably, but at much slower paces. So they do announce it as like an interesting rounding out of their capabilities. Having the ability to do both chemical and electric is, relatively novel. We saw it most recently with the LASSO contracts for the lunar propulsion. A few companies being able to do hybrid chemical electric propulsion. That's not quite what Impulse is doing. These are separate propulsion solutions, but it does give their customers options to kind of choose between the two. I don't really see how it fits into their offering in terms of like Mira and Helios, because those are separate vehicles that are meant to kind of carry around these other satellites. And so having a customer choose electric over chemical kind of undermines the capability of those space tugs. I could see it as like a subsystem sales option, or potentially if they move to more persistent on-orbit logistics, it could be useful to have both electrical and chemical on board, so you can kind of move around in anticipation of higher turnaround needs of potential customers. So overall, I think it's a great diversification of their offerings. I think it's well enough within the kind of band of solutions they're trying to provide. From the pictures, it looks like it's a pretty typical Hall effect thruster, so nothing crazy new on the technology side. But now that they can develop it in-house, that is one of the core subsystems that have been a sort of bottleneck for the industry. So always good to see another company developing them, especially one as capable as Impulse.
Moving on to monitoring updates, Array Labs have raised a $21 million round anchored by Mitsubishi Electric for aircraft and marine vehicle tracking. Mitsubishi was awarded a contract to develop Japan's next-gen defense satellite system, and they're going to be leveraging Array Labs' Airborne Moving Target Indication, AMTI, technology that's going to enable them to track ships, planes, and spacecraft, in addition to Array Labs' already proposed and offered sort of 3D imaging and 3D mapping technology that they're able to leverage using their proprietary SAR technology. Primarily, this expands Array Labs' service offerings outside of the US. They've gotten traction here in the US, and they've been working with the US on breaking into the defense sector because, as we've sort of spoken about previously, SAR has a really high correlation with defense spending, though that's more on a global level, and it hasn't necessarily been a pattern that's been followed here in the US. So Array Labs has very much been trying to follow that same pattern here, breaking into the defense side of things. And it looks like they found a pretty darn good way to do so with the AMTI. So that's something that they've been working on with the US for a little while, though it hasn't been publicly announced. And they've been able to break into the Japanese market for both of their commercial and now defense product offerings with this contract. So big win for the team over there. This is mostly a strategic round. It's led by Mitsubishi Electric, and it's more so effectively one of their biggest customers investing to preemptively pay for the product that they want Array Labs to provide. So they recently closed, I believe, a $25 million round earlier in the year, and have gotten some additional investment effectively through these series of contracts. So congratulations to the team, and we're looking forward to chatting with Andrew and Isaac in the near future here.
Yeah, I find it an interesting development because one of the core capabilities of Array Labs is their radar technology. They have a unique offering in that they're doing more of a fleet monitoring capabilities rather than having one large monolithic satellite, which is pretty traditional among SAR solutions. They do it through a distributed fleet of satellites. But up till now, the SAR technology they've been developing has been in-house. So this funding is intended to use Mitsubishi's payload on Array Labs platform, which Mitsubishi has done SAR before. They did the ALOS 4 satellite back in 2024. So they're no stranger to this capability, but it'll be interesting to see how that plays into Array Labs kind of capability here, because they have a pretty unique offering with their SAR technology. They're already able to do some airborne moving target indications, so not sure why adding Mitsubishi's capability would really change that, but it does give them a good in with the Japanese market. As we've talked about in the past, the Asia Pacific market is one of the most in-demand markets for SAR alongside Europe. So this is a good move regardless of how the tech shakes out. But overall, I think SAR on its own has been really in demand, mostly for Earth monitoring capabilities. But AMTI has been of increasing demand, particularly for missile tracking, although they call out specifically aircraft and ships, and not missiles, but that you can kind of read between the lines, and missiles are an airborne target. So certainly meant for some defense applications here. The most curious thing in their announcement is that they mentioned spacecraft. So there's some space situational awareness capability here as well, which you don't hear a whole lot about. Most SSA solutions are optical. It's not unheard of. A lot of ground monitoring systems use radar to monitor satellites, and there's companies like Think Orbital doing X-ray. So there's no rule that says you can only use optical. But I think it definitely opens up an interesting market for Array Labs. I think it expands them into the Asian Pacific region. It expands the types of targets they can track. I think it makes them more attractive for foreign customers, as well as a lot of the local demand. They've already got a lot of DARPA and Space Force interest in their capabilities. So I wouldn't be surprised if they're, doing some more AMTI stuff for domestic capabilities as well.
Additionally, in the US, Orbez has unveiled their ExoOrb and signed an LOI with Symphony Space. So the Southern Californian startup Orbez has announced an agreement to send their ExoOrb, which is effectively just a free-flying satellite. It's about a 12U CubeSat. They're going to be flying that with Symphony Space's demo mission going up in either late 2027 or early 2028. So it's going to be launching with Prelude, which is Symphony Space's demonstration mission. Symphony Space building a fully autonomous and robotic arm-enabled commercial station, not to be confused with ISS or anything to that effect. It's effectively a module-based uncrewed orbital station that will allow for multiple different modules to be stowed or deployed from the station as time goes on. So it's much more of a robotic sort of gas station, if you will, than it is a research or science station that would need some form of crew or maintenance. But the ExoOrb is planned to take a bunch of pictures of the Prelude when it gets up there, so that they can One, observe and monitor and collect as much data on its performance and how the robotic arms are able to actually service and how the modules are able to stand up while on orbit, and also to sort of provide some marketing materials while they're also collecting all of that actionable data.
Yeah, this is a interesting application, as we've been seeing like third person view satellites become more of a thing. I mean, we talk about it a lot with like RPO, because honestly, this reads like an RPO kind of capability. But for like hosted purposes, it's a bit odd, because typically when we hear about this, it's for like imaging adversarial satellites to learn more about what they're doing, which I could certainly see, this could have those applications. And maybe this is just like the easiest, cheapest way for them to test out that capability before offering it as a defense offering. But, as their stated purpose, it still has some value. We've seen it recently with like the Dodger Dog satellites that Starship launched on the 12th launch that floated around the spacecraft and took video of that. You could certainly see that as beneficial for other capabilities, other rockets that want to monitor their operation on orbit. Like I said, defense applications, certainly as habitats become more of a thing, this could be useful for monitoring. We haven't really seen it with the ISS, although it makes a lot of sense that they would want some sort of capability like this. Is just kind of coming so late in the lifetime of ISS is kind of surprising. So, I think it's a good endorsement from Symphony Space, although they're also a very early space company. So it's likely there's not huge dollar amounts attached to this, and it's more just a partnership and an early use case for Symphony's stated purpose, which is kind of like a hosted platform where you could swap out payloads. And this could be one of those applications, and it could be useful to just, maintaining the operation of that persistent platform. So overall, like, good partnership. I think it probably benefits Orbis a bit more towards developing their technology, but I could see it being useful for, persistent habitats and persistent modules like Symphony Space.
Beijing-based startup, the Xingchen Daohe, raised $14 million for a space situational awareness play. They will be building a constellation that is funded to support the tracking of orbital objects, and it represents additional resources that China is committing to maintain their competitiveness in the space situational awareness and space domain awareness areas. Effectively, there's a lot of defense implications for having an edge in either SSA or SDA. So if you're able to track debris, or if you're able to track satellites that are flying dark or trying not to be seen, but if you're able to have an information asymmetry, if you're able to know more and have a better data set than an adversarial player or than another entity out there or another player out there, that information is incredibly valuable. So I wouldn't necessarily say that this represents China trying to gain sort of an upper hand. The US has been prioritizing space situational awareness and space domain awareness with a supreme premium for the past several years. So this doesn't necessarily represent any sort of major power shift here, but it does reinforce and underline the fact that the verticals, or the areas of space situational awareness and space domain awareness boil down to a data moat. And so having the best and most robust data for those veins winds up providing meaningful competitive advantage for the space domain as a whole. So I would be astounded if we don't see further investment out of China, the US, Europe. I would be astounded if this isn't a sort of ongoing and continual global trend. Speaking of space domain awareness and space situational awareness, Spaceflux was able to identify that Intelsat 805, launched in 1998, has broken up in a graveyard orbit. They were tracking the breakup, and they've been able to backtrack and effectively estimate the breakup to occur roughly at around 2000 hours UTC on July 29th. This is very interesting for a couple of different reasons. The first of which is that Intelsat 805 was in a graveyard orbit. So way, way, way up there, 35 or 40,000 kilometers up there. Geo orbit is typically 30 to 35,000 kilometers, and graveyard orbits are even further out than that. So this was way up there and effectively blew up. And I believe the number that SpaceFlux quoted was order of magnitude 500 pieces of debris that they've been tracking as a result of the collision or the breakup, which points to a couple of different things. That, you know, the idea of a graveyard orbit is that rather than deorbiting a massive satellite, a 3,000, 2,000 kilogram satellite up at 30,000 kilometers altitude, rather than bringing all of that mass all the way back down to Earth, we'll just push it a little bit further up where it's not going to bother anybody. You know, that works on paper, but the problem is that it's just going to be there forever. So, you know, the fact that something is up there in the graveyard orbit permanently means that a collision as a result, or something just plowing through it up in that altitude, it's just an inevitability. And so depending on sort of what that debris cloud winds up looking like, it could actually adversely affect the valuable geo orbits beneath it, and very easily can cause problems for some of the other assets in and around graveyard orbits. And this does not consider in any capacity some of the RPO mission extension mission models that we're seeing developed or come into account. So the idea of a graveyard orbit being a permanent solution for something that we want to get rid of, it never was the perfect long-term solution, and we're starting to see some consequences of that.
Yeah, it's unfortunate reality that's coming to bear. It's kind of crazy that this isn't the first time. Like, Slingshot detected the Launch Olymp breakup beginning of the year, and before then, that it had been largely thought that Graveyard was pretty safe from these events. You know, there's always a really low risk of like a micrometeorite impact out there, but you know, there's nothing that's indicating that's necessarily the case. At least with the Launch Olymp, it was suspected that it was a collision with another satellite, which at this point there's only I think it's on the order of 100 satellites that are parked out in Graveyard. It's probably only a couple hundred at most, just given that, you know, geocomms have been around for a while. That's been the way of disposing them, but we haven't put that many satellites out in geo over time. Yeah, to your point, it's a really bad place to have a breakup. You know, the volume and likelihood of a collision is very low, but because it can't be removed very easily, like we can't clean up debris in geo like we can in LEO. The amount of energy to move around and pick up these small pieces is just prohibitive, at least with our current technology.
Your trash on Everest stays on Everest.
Yeah, no, that's a great way of putting it. And it's still relatively easy to avoid it. Like, nothing really flies out that far. You can sort of fly around it if you need to go interplanetary, but it's not great. Like, you don't want a trash ring anywhere. You know, of all places, maybe that's the best, but it's still not preferable. I think it is a huge boon to programs like the MRV or the MEV. And we have other ones like Catalyst's Nexus program and Impulse's Helios spacecraft. So, you know, there might be increasing pressure for those kind of capabilities to get us away from the graveyard orbit solution, and more towards the deorbiting or even longer term lifetime. You know, I think I would prefer to see this as pressure towards more persistent long-term solutions rather than just now geo gets deorbited as well. You know, of all the times for this to come around, I think this is the best. I'm just hoping that we don't see any more breakups in Graveyard before we kind of realize that something else needs to be done about our management of geo assets. because this is very unfortunate. It's not Intelsat's first breakup either, so not great for them. Although I don't think it's their fault. I think the 33E was the other breakup, but I think that was in Geo, and it was like a battery pack problem. So this is not likely anything that they did.
Intermap has agreed to acquire the remaining shares of PCI Geomatics for roughly $11 million. So Intermap Technologies announced on Wednesday that they were going to acquire all the issued and outstanding shares in the capital of PCI Geomatics that it didn't already own for just about $11 million in cash. The acquisition integrates the entirety of PCI's satellite and aerial image processing and microservices with digital elevation models that Intermap already owns. They're expecting about 60%, give or take, of pro forma revenue to be generated from recurring commercial subscriptions and repeat contracted licenses. They're getting a whole bunch of the value of acquiring PCI Geomatics for a very valuable price point here. This sort of indicates to me is that Intermap got PCI Geomatics under some pretty extreme duress. PCI was for whatever reason having difficulty growing revenues and growing sort of their stock price, so that Intermap was able to just follow through on the execution and wrap them up.
Yeah, I thought the phrasing was the funniest part of like acquiring the remaining shares. It was like 99.6% of their shares. So I guess they had invested them in their Series B, and that's how they had some ownership. But they're basically outright buying this company, which I think there's some value to be had here. It feels like it's a bit like they're formed at a time where it made a little more sense, and there's kind of being some shift in how imagery, Earth imagery, is valued for as a space application. But this is much on the side of like intelligence services, and we've seen the shakeup, less data being transferred down to the Earth for geospatial knowledge and more being processed on orbit with things like edge compute. I could see this being kind of a consolidation of capabilities that was probably made more sense for the previous kind of iteration of Earth imaging, and maybe shifting this more towards something that makes more sense with edge compute in the loop, and the kind of shifts we've been seeing in SAR capabilities, as well as new forms of Earth imaging.
Ending on some unfortunate news, the Galaxy Drishti died on orbit and was sort of formally announced a little bit earlier this week, but the first ever Optosar satellite lost communication with the Bengaluru-based startup Galaxy after a geomagnetic solar storm damaged its systems. The CEO of the company confirmed that earlier this week. The mission was largely successful prior to the solar storm itself, meaning that future missions will only really need to be rated for a harsher environment in order to reliably achieve similar success. So despite the setback, there's a pretty clear path forward, assuming that the solar storm is the actual sort of root failure cause. However, Galaxy remains undeterred. They're still on track to launch 2 more versions of this same satellite, each of which roughly 300 kilograms in size and mass, over the course of the next 20 to 24 months, give or take.
Yeah, find it surprising that they're blaming this on a solar storm. There was one in July, but it wasn't like crazy strong. And then they flew on a transporter, and none of the other vehicles are experiencing this problem. To me, it reads like their concept of operations didn't account for shutting off during solar storms. They weren't able to shut off in time. Usually that's the way you avoid getting damage to your equipment during a solar storm. Hardening their system against one seems like the way more expensive approach to this. That's not usually how you handle it. If they're looking for like maximum uptime, then maybe it makes sense. But usually solar storms are so transient that you kind of just put the satellite to sleep during the thick of it to avoid damaging any components that are charged at the time that all this radiation is passing through. So really unfortunate for Galaxy. I hope they learned the right lesson from this. It is a pretty unique satellite. I mean, talk a lot about SAR satellites, but combining optical and SAR on one satellite makes for interesting capability, particularly more so, especially when we're talking about like edge capability, because being able to blend those two together on board the satellite makes for a pretty unique offering. There's plenty of systems that can blend optical and SAR, but usually they come from separate satellites and are merged on the ground. That means delay to data delivery and all of that. This could provide a pretty unique offering. So really unfortunate for their first mission. I hope they're able to, figure out a way to avoid this problem in the future and get back to flight soon.
On to the business moves for the week. The Space Systems Command awarded almost $1 billion to 15 different companies. The U.S. Space Force awarded $981 million for space test and training contracts to 15 different companies, including Firefly, Redwire, Rocket Lab, and York Space Systems, among others. The task orders for this contract include the deployment and integration of space-based vehicles and systems, the deployment of ground systems, the creation of digital environments and twins, as well as some fleet and sustainment management of operational systems and enterprise-level enhancements focused on resilience and automation. Really, what I sort of read from this, the big takeaway that I had, is that there's a fundamental layer of infrastructure that they're looking at investing in further in both the orbital and ground segments that they are building out here. And more importantly, I think, is the Space Systems Command leaning into and pushing for a higher rate of adoption for AI-enabled missions. The fact that they're investing effectively in digital twins, digital automation, and the sort of automated sustainment management and operational system management, all of that reads and sounds like a series of different products that are all fundamentally based on different AI models running in the back. So it reads very much like a pretty explicit investment from the U.S. Space Force into AI-based missions and more AI-enabled missions, I'll say, moving forward.
Yeah, there were a lot of announcements this week about this kind of modeling and training capability, and it's one we've seen week over week for probably the past 2 months.
Absolutely.
A lot like the conspicuous ones to me here, like Firefly and Rocket Lab with the Victus Haze missions, having this increased responsivity in space requires better simulation and modeling and planning and training for more dynamic space capabilities. In the past, everything's kind of been set, everything's kind of been planned out ahead. Space has been a very static kind of system. That's changing rapidly across the board. And so I think this demand for training capability is increasing in stride. And the fact that the companies are spread throughout the industry, like 15 spots here, I think you're about to mention another one that covers another 29. It's like, it reads to me like it's a call to the entire industry that we need better tools to operate your spacecraft, not just, hey, here's how you send a command. It's more of, hey, here's how you simulate some situation arising or simulate some change to the concept of operations or the mission deployment or stuff like that. So, I think in the past, the tools they've been looking at, like we talked to Quindar about like integrated mission planning tools. We've seen a lot of announcements about integrated systems that handle heterogeneous fleets across all the different assets that the Space Force manages. I find these announcements interesting that they seem more targeted towards the specific manufacturers and operators that they're buying from. Like they want better insight into the capabilities and kind of the operations of the capabilities that they're fielding.
This is a trend that we've seen. This is a clear priority that we have seen, even if it's not as clearly articulated as saying in so many words, hey, we need the latest and greatest when it comes to AI capabilities for the entirety of our space infrastructure. But that's basically what it boils down to. And to your point, I mean, the U.S. Space Force selected 29 companies for their Adaptive and Intelligent Space Challenge, very similar to the prior announcement with the awards for space test and training. But the Adaptive and Intelligent Space Challenge is a little bit earlier stage. It involves more, I'll say, research than actual execution. They selected 29 companies to accelerate the development of targeted emerging technologies, and those emerging technologies are orbital compute, sensing, and orchestration capabilities. Again, all of which overlap, the Venn diagram for what AI-enabled products and services for the space industry claim they can do, almost a circle with orbital compute, sensing, and orchestration capabilities. So very clear overlap with the Space Systems Command Awards, and there's clear money behind the stated priorities that we've seen coming out of Space Systems Command, the Space Force, and the DoD.
Yeah, these companies are a bit more on the other side of the trend that I mentioned, but it's more to do with tools that aren't specific to any one company, but allow them to do more advanced capabilities. Like one of the companies was AirDrive, who we interviewed before, and their capabilities have more to do with on-orbit space situational awareness. And I think that fits the trend of most of these companies that were selected, is having something that's more capable on orbit, that's able to, as the name suggests, adapt and intelligently react to situations. So I think the previous announcement was more for like training and digital twin and modeling and keeping track of stuff. This contract has more to do with fielding new capabilities that allow these systems to kind of react outside of the realms of what was originally planned. So it really, between the two, I feel like it covers both sides of the problem. Space is much more dynamic. We need better ways to prepare for that, but we also need better ways to react to when our preparation isn't what was planned.
Meanwhile, K2 Space raised $500 million in a Series D round led by Kleiner Perkins and Iconic. The round places the company at a $6.8 billion valuation as K2 Space aims to scale their Torrance, California manufacturing capabilities to target and hit 100 of their large-scale satellites on an annual basis. They've now raised over $1 billion in total capital and have secured over $1 billion in combined commercial and government contracts and awards to date. Their high-powered and high-mass satellites are already proving to be in demand for both commercial and defense purposes. And one of their biggest sort of claims to fame, one of the biggest reasons why they've been able to achieve this success, in the words of their CEO, being attributed to their quote-unquote 85% vertical integration for their supply chain. So they're able to do 85% of everything that goes into orbit in-house. And so they effectively own and control the vast majority of their supply chain here. So their next upcoming mission is going to involve multiple satellites going up in Q2 of 2027, titled Trinity. But they are focusing on a second half 2028 launch date for their Giga class satellite, which is the 100 kilowatt satellite that they've been building towards to use as sort of the foundation platform for deploying orbital compute.
Yeah, this is a huge raise. I mean, they've raised a lot of money so far.
They raised $250 in their Series C. Wasn't that earlier this year?
Yeah, that was like a couple months ago.
Yeah.
And that SES contract they got was roughly around $500 million by my calculations. So they've just been raking in the money. It's good to see that it's on both sides, like it's contracts and it's money raised. I still feel like they're kind of out over their skis on this one. I think there's a number of factors here, and I don't think the valuation is totally unreasonable. I think of all companies, like they're one of the most promising, but I think there's still a lot of risk associated with this company as they've only launched one spacecraft so far. They had an amazing first launch. Everything seemed to be working great on their first time out, which is pretty rare, especially for something that's pushing the limits so much. 20 kilowatts isn't unheard of, but it is way far on the large side of powered satellites, especially for LEO. Like we've seen above 20 kilowatt satellites, but they've all been in GEO. So this is the highest power satellite in LEO. I do think that, their stated goal is to reach 100 kilowatts. That's where they expect to kind of make most of their money. Some of the data center aspirations kind of sit in that realm. And I think that's probably where this inflated valuation is more so coming from. But I think there's definitely some tailwinds they're getting over high power buses. I think they were one of the first to recognize that, which I think gives them a lot of clout. And it's one of the main reasons why I think, they deserve to be funded to this level. But I think we've talked before. I think one of the downsides is their stated goal to make just like large satellites. I don't think the size itself is all that beneficial, and it bets heavily on SpaceX and Starship becoming operational, which has a number of risks associated with it. One is that Starship still isn't operational yet. And, I think it's expected to be operational this year at this point. The next launch is kind of expected to be the first operational flight. But even once it's operational, like, it's not designed to host this kind of satellite. And given SpaceX's recent track record with kind of leaving satellite operators high and dry with the abandonment of transporter missions, I'm not sure how much you want to count on SpaceX being in your corner when it comes to providing like the clamshell design for Starship, which is necessary for their 100 kilowatt satellites. So there's a little bit of risk there with the launch provider. I think a little bit of risk scaling from 20 kilowatts to 100 kilowatts is not trivial, but given their track record, like, I'm sure they can figure it out. It's just a lot of like this money is coming on a timeline that's largely speculative. Which I think is a risk. Again, of all companies, like, they have a great backing. They have a great background. Like, their founders are, coming from SpaceX and past ventures, and their brothers, and like, of all companies to back in the space industry, they have a very ambitious vision, and I think they're going to be able to execute to it. I guess I'm mostly worried that like these investors are putting in this money expecting to see returns on a near-term timeline. I think these timelines are going to slip, not all at the fault of K2, but just the fact that, like, yes, space is speeding up. I don't think it's speeding up by the timeline they're looking at. And seeing some of the bigger names like Kleiner Perkins, like, it's a great endorsement for space becoming more of a standard investment offering, to see something like that on this raise. But overall, it's going to be a real challenge, but really interesting one to watch. And I think they're going to be leading the way in kind of the shift towards bigger satellite capabilities.
Speaking of competing with SpaceX, the exploration company has announced plans to raise $300 million at a $2 billion valuation. While the deal isn't finalized, there's backing from European investors, some folks out of Sweden. I believe SQL were looking at investing and leading the round. So the Munich-based competitor to SpaceX, this investment really underscores how much Europe wants to avoid being reliant on SpaceX for anything. So the exploration company, they're building the Nix capsule, which is the Dragon capsule that SpaceX owns. It is a crewed, human-rated capsule or cargo-rated capsule. But this is what you put stuff in that you send to the ISS. That's what the exploration company has been building and developing. They're raising $300 million at a $2 billion valuation for that layer of the cake. We've already spoken extensively about the multitude of different launch providers that the EU and ESA are vetting and putting money behind to accelerate their launch capabilities and bring them on par and make them competitive with the offerings available more broadly across the globe. But I think that what jumps out to me here is that this is a very high valuation for a company that has yet to deliver on anything, though to their credit, the exploration company has over 770 million in contract backlog. So they have a lot of folks wanting to use their capsule, wanting to actually plan missions with them. And they do need to execute on that. But it's what this says to me is it highlights the sheer magnitude of the premium that Europe is willing to pay so that they are not dependent on a foreign provider for anything.
I feel like they've been really distracted recently. Like, they just bought an electric propulsion company, which didn't make any sense to me. Like,
they made a couple of those acquisitions, yeah.
Well, do you know the other one? Because the other news we recently talked about was them like expanding into the U.S.
Yeah. Well, didn't they expand into the U.S. via acquisition?
I don't think so. I think they just said they were.
Or they just stood up a Virginia effort?
I think Texas. I think it was in Texas.
Okay.
Because I was speculating that they wanted to like partner with Firefly or something, like some other rocket provider. Since they don't have a rocket, like they would have to fly on like a Soyuz or a Falcon 9, in which case they're not competing with SpaceX. And the Soyuz isn't European, and I doubt Like if Europe doesn't want to be dependent on SpaceX, but instead dependent on Russia, it's not like a good trade-off. It's like out of the frying pan into the scalding hot fires of Mordor. Like that's way worse. So
yeah, sounds right.
Just overall, I feel like exploration company needs to focus on delivering. Like you said, they haven't launched anything yet. They've been at this for a while, and their first launch is until like 2028. So I don't know. Like I think all these contract backlogs are kind of incestuous, and that the EU really, really wants this company to exist, and that's what they've been supporting them with contracts. Like they were as like a planned European expansion of the space transportation. So I think they got contracted around the time that Dragon and Cygnus were, and they just haven't been able to deliver. So it just, to me, it feels like there's a little bit of a lack of focus on their core offering. There's some vibes I'm getting that they're expanding their offering to try to bring in more money. I'm finding it interesting that they're able to raise so much off of like lack of execution, and specifically towards their next capsule. So overall, this just to me, it just feels like Europe is just wants to back this company no matter what. They're refusing to let them fail because they just need this capability, and maybe they are the furthest along in developing this capability. So if they were to let them fail, it would just be starting back at square one. Like they don't want to give up on this capability, and they're just going to keep funding it until it exists. So I feel like it's really capital inefficient, just inefficient from an execution standpoint. But I also feel like it's going to exist at some point. Whether 2028 is a successful first demo or not, that's yet to be seen.
Meanwhile, Outlier Space raised a $7.3 million pre-seed round for reusable capsules led by GD1. So Outlier Space, the New Zealand-based company, closed its pre-seed round to develop a microgravity payload capsule that is currently compatible with ISS lockers. They made the announcement earlier this week. Jamie France, CEO and friend of the show, is particularly proud of the vote of confidence that this fundraise speaks to New Zealand's space industry, and the industry expertise and quality that is available in the New Zealand market. I'm really glad to see them getting this investment and traction. I think that the downmass market as a whole and orbital logistics markets are big problems that need to be solved. Candidly, I'm a little bit relieved to see that they got this investment after the Starfall mission. So what this says to me, the fact that SpaceX sort of, hey, surprise, we do downmass too. We do downmass from the ISS too. And they released the basically refurbished and repurposed Dragon capsule for this exact mission. The fact that folks and investors are willing to invest in folks that are effectively directly competing with that capability tells me a couple of different things. It tells me that they view either the space logistics market as so big that it's not possibly going to be winner take all. It tells me that they believe there's going to be a meaningful sort of first mover advantage. So they want to be investing in folks who are doing this now and who are going to be able to be some of the first people to start providing solutions. It tells me that they believe that there's more opportunity for collaboration than direct competition. Now, this could also mean that these particular investors have no idea about Starfall, that maybe they just missed that announcement. They were unaware of the mission, and so they don't realize that they're in the business of competing with SpaceX. But
wait, what?
Yeah.
SpaceX did what?
But I will give them the benefit of the doubt that they know what they're getting into, and that sort of this is what they're doing. They could also just know more information than us. So they could have sort of the insider track and know that SpaceX actually doesn't view this as a super lucrative market, and that SpaceX isn't actually planning on getting super competitive and diving into this. that this was just something that they were sort of working on the side. And it's like, okay, yeah, that's fun. We think the market's too far off for us to really prioritize this. So there could be a lot more going on, but the top level takeaways are that, like, okay, great, SpaceX proved that the market is the product market fit is there, that the market is valid and valuable. We think that this is so big that the fact that SpaceX wants to participate in this market doesn't scare us away from wanting to participate in it either. And we think that we're able to move quickly enough in this market to get a meaningful edge and to get a meaningful market share that will keep us around for a long enough period of time.
Yeah, I think the thing that stands out to me is that it's compatible with ISS lockers. So I think it does differentiate it a bit from what Starfall does. To me, Starfall is more of a standalone, free flying capability for mass production on orbit. I think even with that fully capable, there's still a large need for, human in the loop development of capabilities. So not everything that people want to manufacture on orbit can be done by some robotic foundry. Those applications I could see, you feed stock into the foundry, produce it, bring it back down. That's fine. But I think that still leaves a lot of room for companies that want to host the foundry on orbit, not necessarily send that up and down with every launch, and rather have pods that can attach to things like on-orbit habitats, whether manned or unmanned, kind of like Dispatch, when they came out of stealth a few months ago, proposes. Starfall kind of exists to fill a very particular niche, and not one out of, like, they chose that niche. More like, hey, we already developed the Dragon capsule. Why don't we just cut off the capsule part and use the shield part? And they're just trying to make money off of that. But I think it leaves a large section of the in-space manufacturing market for some of other applications, particularly ones that are more highly manipulatable or under development. So I think what they're stating here kind of fills that need a bit more and doesn't necessarily compete head to head with what Starfall is offering. Lastly, for today, we have our tech advances. One of them is a little bit of a disadvantage. Unfortunately, Catalyst Space's Link spacecraft has suffered an anomaly on orbit where they lost two of their I heard 3 reaction wheels. Normally people carry 4. So basically they lost 2 of the reaction wheels, which is very unfortunate. You need reaction wheels to maintain control of the spacecraft, and that's exactly what happened when they lost them. They lost control of the spacecraft. It went into a 9 degree per second tumble, which is pretty fast. They lost communications for a little bit until they figured out what was happening. And then once they did, they were able to establish communication long enough to command their 3 gimbaled electric propulsion thrusters to slow down the tumbling to 4 degrees per second. So now they're in a pretty well-controlled tumble where they're able to communicate with the satellite. They are working with NASA to come up with a new control scheme to hopefully recover the spacecraft. But this does set back their mission with a rendezvous now planned for no earlier than the end of August. Catalyst Link spacecraft, my opinion, the coolest mission going on this year, which is saying a lot because there's a lot of cool missions like Victus Haze and Starship's constant launches. But this spacecraft was developed on 9 months, $30 million budget to lift a spacecraft out of 300-kilometer orbit, which is VLEO. Nothing flies in VLEO except apparently the spacecraft that was thrown together on a short timeline with a shoestring budget, and was going great up to this point. I mean, there was like a solar storm that got in the way of Swift staying on orbit. There was monsoons that kept them from launching. So Mother Nature is just throwing everything at them. And it seems like they run into the latest challenge. I think they'll be able to stay alive with 3 thrusters and a reaction wheel, but it's going to make it really hard to rendezvous with another spacecraft. The schemes that you use for, rendezvousing require a certain level of agility. It's not as easy as just go straight at the object. You have to enter into what's called a circular orbit around the other object and kind of descend upon it. And that requires, a level of pointing that allows you to use your thrusters, of which they have like 16 cold gas thrusters to get into. So, they use the electric propulsion thrusters to slow down the tumble. They have cold gas thrusters on board. Usually that's used for desaturation of the reaction wheels. I could see them potentially using those as active control if they packed enough fuel on board to accomplish such a thing, then I could see this cooperation with NASA coming up with some sort of control scheme that uses all of their thrusters as well as the reaction wheel to get back to full 3-axis control and get connected with the spacecraft. That in itself is a huge challenge. The other challenge is, if they eat too far into their fuel margins, they won't have enough fuel to get Swift back up to the orbit they need to. What could possibly happen is they get Swift to a high enough orbit that it survives for another year and they can send up another one of these spacecraft, but there aren't any Cygnus launchers left. So, overall, there's a lot of challenges here. Catalyst has done a great job of solving really difficult problems on a tight timeline. This, I think, is their biggest challenge yet, but I am still hopeful that they are going to be able to figure something out. I don't think their mission's over. I think they're going to be able to find some way to continue on, but I'll be biting my nails watching that rendezvous operation because it's going to be really tricky to do without their full control system online. So best of luck to Catalyst. I hope to see them meeting up with Swift at the end of August here.
Fingers crossed and hats off to them. Best of luck.
Lastly, for today, we have Intel debuting their Starfire chip. This is for AI in space. The Starfire chip uses a Panther Lake 8-core CPU with 3 NPU tiles and a Intel 3 GPU. So this is a system-on-a-chip solution that is intended to be low size, weight, and power. They have a 10 and a 35 watt option. So 10 watts, pretty low power. 35 watts, a little more standard. So it's a pretty solid offering just off power numbers alone. I found the temperature range to be particularly interesting. -55 to 125 degrees C is a pretty large range. Typically we see like -30 to 60 degrees C. So this is sitting on both sides of that range. The 125 is particularly standout to me. They weren't very specific if this was for like orbital data center AI or like edge compute AI, but this temperature rating makes me think they're targeting kind of the potential to do orbital data center AI. The part that makes me think it's more for like edge compute AI is they're competing primarily with the BAE Rad 750. So this is a PowerPC solution. I believe they do this through Global Foundries. So it's also a US native chip solution, which is why it's flown on many Mars rovers, and they listed 150 satellites. So they're going up against an incumbent that's been well flown with lots of heritage. It's been on a lot of missions, and it's going to be hard to compete against with Intel's solution, especially given that this is off of an older GPU. So it's still a lot newer than what BAE fields on the 750, but it is behind the most state of the art, just to give it some more radiation hardness, just by sake of the transistors not being as small as in some of the more cutting edge chips. So the big risk I see here is they still haven't characterized their total ionizing dose, their single event latch up, or their single event upset kind of hardened rating. So they're putting that through testing right now. That will be pretty critical, I think, before anybody actually flies it, to see how resilient it is. But they're stating a 10+ year lifetime, which should put them in in contention for some GEO missions. Obviously, it's above that 5+ year lifetime of LEO missions. It's very capable at 45 to 75 tera operations per second. Although I believe that puts them behind the next BAE chip, which is the BAE Rad 5545, and is 100 times throughput of the Rad 750. So, it'll be interesting to see which niche this kind of fills. That GPU could be interesting. I could see it potentially being fielded for orbital data centers just because of the bottleneck on GPU capabilities. But a lot of the interest in this is through defense contracts. So RAMP-C and SHIP programs from the Pentagon are funding a lot of this development, and they're intending to reach production by 2027. So, this reads to me a lot like they're trying to shore up domestic production of critical components, compute chips being one of them. Just like 150 satellites is a lot of satellites for heritage. It's not when it's compared to like constellations of satellites. So to me, this reads a lot like the Pentagon is trying to fund development of a component that's going to become more and more critical as we fly more and more satellites. And having a company like Intel that's domestic being able to produce them at scale is kind of more critical than being able to produce something that's like the most cutting edge, most capable chip out there. But great to see another option on the market. BAE's kind of been stalwart for a while. We've seen some news out of NVIDIA starting to focus more on space applications. It's just good to have options. As you say, monopolies are not good for anyone.
That is a wrap for the week's recap of the space industry. We hope you enjoyed the episode. As always, please drop us a comment, check out our socials, and follow us on Spotify, Apple Podcasts, YouTube, Substack, or wherever you're receiving this signal. Until next time, this has been Paul Mayer and Harrison Lambert signing off for now.